Morning, everyone. I'm Ken Geary, Director of Ostick Williams Architects in Belfast, and also presenting with me today is Mark Tracy, our BIM manager. We've been going for 65 years as an architectural practice. Last 4 years, we've really got into BIM. That either puts us ahead of the game or a long way behind it, I'm not quite sure. But we are very committed to BIM. We looked at ourselves in the recession 4 or 5 years ago and thought, what sort of a practice do we want to be coming out of the recession? And we saw very much the adoption of BIM, the policies, the procedures, systems, software, hardware, all of that stuff could be developed and implemented through a partnership like some of the other talkers that have spoken today already through Innovate UK, through the Knowledge Transfer Partnership, which we have with Queen's University. So that's a little bit of background about us. I'd like to talk to you about the Centre for Experimental Medicine. The white one?
The white.
The white. That would help. Here we go. The Wellcome Wolfson Institute for Experimental Medicine is an innovative and pioneering biomedical research facility. Laboratories are arranged around a central atrium, which encourages collaborative working within transparency across the building between research spaces. The concept maintains a clear adaptable floor plate, free from service risers, by routing ductwork vertically on the building perimeter with an energy-efficient double-skin facade. The building itself celebrates the science that occurs within it and is an exemplar of sustainable and carbon-limiting laboratory design. BIM was successfully used as a tool for design development, fabrication, installation, and operation of the facility. During the design of the Institute for Experimental Medicine, the Queen's University Estates Department team needed to carefully consider the issue of whole life costs in relation to highly serviced nature of this facility. As such, the client had seen the construction of the Institute as an opportunity to review its portfolio management processes during construction and post-completion, and therefore BIM for FM was a key driver for the implementation of BIM during the project process. The Institute has been at the cutting edge, therefore, of BIM as a pathfinder project in Northern Ireland. It was successfully used for design development. It has broken new ground for Queen's University, as the information stored in the BIM model is currently being explored for use and transfer for facilities management. And we're involved in that process still with them. And the use of BIM in the project has been a pathfinder to derive efficiencies and lessons learned that can be applied to all future projects within the university. So key to the change program for the university was the communication of that change and adequate support throughout. The client acknowledged that to be truly implementing COBE as a requirement for the pilot project and future projects, there would need to be an internal change of procedures and documentation. And Mark will talk about that a little bit later in the presentation. As it was a pilot project for the integration of BIM, the building execution plan stipulated a hybrid of data requirements, including the addition of custom shared parameters aligned with the project asset register. COBE was also prescribed as a requirement, and as such, the project team sought to populate the models with COBE parameters and complete the model with relevant information in advance of handover. Some images of the design concept. We started the project working in 3D modeling. The site was very complex and constrained, and 3D studies supported the pre-planning design process. In terms of sustainability, the lab buildings are intensive energy users, typically using twice the energy of a similarly sized hospital. This provides a significant challenge to the client's desire for a low carbon design. However, the Institute has exceeded all targets. The 3 R's reduce, recover, renewable approach has been successfully applied after consideration of life cycle cost options for each. Specialist software, IES, environmental modelling software for the analysis of the building performance, was employed from the early stages of the project to calculate the anticipated energy consumption and therefore facilitate informed decisions to minimise the long-term environmental and operational costs. This is really one of our main drivers for adopting BIM, is to practice evidence-based design, to give the client really reliable information at the early stage of the project through the model that will predict the running costs of the project. So it's not just a capital cost issue, it's very much these days a running cost that informs the business case analysis. The result of such extensive testing was the harmonisation of the site massing, internal loads and the layout of the natural climate and site conditions. Design decisions which arose from the process included the addition of a double skin facade to regulate the internal environment and act as a preheater for HVAC systems, the inclusion of natural ventilation and the control positioning of natural lighting. In use, these strategies have proven effective in delivering a design solution that takes account of intense energy needs within the lab environment. So the drivers for BIM: accurate works information by consistency of drawings and reports, collaboration and integrated team working, validation of the process in an ongoing way by interrogating the model, clash detection of the model to, we're all familiar with that, to work out problems well in advance before they get to site, lean techniques to minimise waste in design and construction effort, and simulation of safe working methods and logistics planning. Program was an extremely was a big issue for the client, an extremely challenging exercise involving pre-construction coordination of fabric, structure and complex M&E systems. The construction on a very constrained site surrounded by sensitive activities was modelled out, and the project was completed on time, and the adoption of BIM Level 2 has been credited as one of the key reasons for staying on programme. Pre-construction coordination was done very well. The M&E Revit model was interoperable with the fabrication of ducting, pipework, cable trays and supports, which increased its speed and minimised waste and resulted in very few instances of delays. The process also allowed the contractor to adjust the installation sequence by maximising off-site fabrication, which delivered time benefits to the project. In terms of quality, the completed project is a very good appearance in terms of the internal and external finishes, and this also extends to the installation of systems that are mostly covered up at this stage. But the standard of this installation has greatly benefited from pre-construction clash detection and off-site fabrication. The project was the overall winner of the Northern Ireland Construction Awards last year, and the use of BIM was cited by the judges as having made a very positive contribution to the high quality of the completed project. In terms of cost, the project has been delivered to the capital budget. Reporting has been very thorough and consistent through the construction period. There have been very few site changes, outstanding RFIs. To throw the project cost management off track really were absolutely minimised and dealt with very quickly. And the estate directorate has no doubt that BIM Level 2 has improved the predictability of cost outcome and positively influenced the successful management of finances. In terms of site logistics, space was a very constrained site. Business continuity, the immediate vicinity of the site remained active with research and treatment taking place during normal hours, and construction logistics and phasing were carefully considered in advance. The use of 3D modelling during the design stage helped all of this, and prior to construction ultimately fed into what was a very efficient and lean programme, including the testing of crane turning circles, tracking of vehicles to give client and project team greater confidence in proceeding through to the construction stage. And finally, in terms of client engagement, Queen's have been proactively engaged in the application of BIM in the Institute project as a pathfinder to learn lessons with the view of realising the benefits across the entire campus. And the drive started at director level, which I think was really fundamental, and that is been the key reason, I think, that top-down approach has been the key reason for the successful implementation on BIM on this project and as they go forward. Regular BIM coordination meetings improve day-to-day construction management and acted as a means for the whole team to work collaboratively. And soft landings have actually extended our involvement in the project over a 3-year aftercare period, during which time we're looking into all of these issues of the use of the model for FM. I'll hand over to Mark and he'll take you through the rest of the presentation.
Okay, so whilst Queen's are now embarking on a research project into the FM solution that they can integrate their handover models with, they in this project, this is their first, they also wanted to use the model as part of their O&M operations. So we needed to develop a strategy for that, and what we did, we created a digital O&M, extracted out the drawings, but also made the hyperlinked interactions with the actual Navisworks models to encourage the use of it instead of it becoming a static document. One of the key areas that we embarked on was the use of collaboration between the team. This included the design coordination meetings took place regularly over the construction period between the designers, contractor and client. Ostick and Williams took care of that pre-construction and the contractor during construction. Models would have been uploaded in Navisworks format 24 hours at least prior to the actual workshop itself. In the manner of those workshops, we also made a strong attempt at actually making the models relevant to the purpose of that meeting at hand, including the client being there as well. So a couple of strategic decisions were made to, first of all, add coloured filters to the M&E systems in order to everybody to engage with the model better. We added search sets in order for the team to be able to take off and add on what they needed. But we also created starting views just in certain rooms in order to engage and make the meeting run a lot smoother. Subsequent to this, there would have been a number of reports issued given to the design team and the contractor for rectifications of any issues. This next video shows can I have a feeling it's going to happen? Okay, so the video doesn't seem to be working, but the video depicted essentially our novel idea towards interaction with the model and the 2D information. By talking to the actual FM team, it became apparent that they still required the 2D information to be able to engage with the actual information contained within. So what we did was we combined DWFs, which contained global unique IDs, with the actual Navisworks model. With the actual Navisworks model, which allowed the participant to not only view the 3D model, but they could also go to the actual 2D drawings within Navisworks, click on an item, and be able to actually engage with that item in 2D and 3D. Okay, so I got the video here actually. So as you can see, we extracted the exact drawings from the model in DWF format, which is a 2D format. This allowed the FM team to be able to access the 2D information, but not only that, they were able to select the component and be able to view information that was actually relevant to them. So it was a hybrid of acceptances. And as you can see here, we could select the component and see any valuable information that the client at that time had asked us to embed into the information to help with their asset. But not only that, we also then decided that we could also produce a Navisworks federated model, live model for change processes, in which case we added the colored filters, as well as the ability to actually pull apart the model itself and interrogate it. And as you can see here, we're able to navigate around and view one of the floor plates. So this is trying to engage the FM team and encourage them to actually use what they have with them. We also started to create, and we did create a number of starting viewpoints of every room, so that whenever they engage the model, they could actually go in and view the room very easily. This is as a way of promotion for them to get away from their previous activities of wanting to access 2D information or go on site, which is the popular benefit of it.
1 minute, please.
Sorry. Okay, so what you can see now, we also added in the DWFs into the model. So they combined with the 3D Navisworks model. So not only in the Navisworks model could they see the 3D, but they could go in now and actually view the 2D information of that model. But the interesting aspect of this is the fact that they can see it in 2D. They could also click on the item and subsequently view the model in 3D as well. So as you're seeing here, there's a list of different views that show that same item. So it's a hybrid of the 3D model and the 2D, really. So, and you go back here again. Yeah, so I'll just click on that. Okay, so lessons learned. Even as the project was drawing to a close, the QEB Estates Director was actively establishing a BIM implementation group in combination with the industry embedded specialists, including ourselves, tasked with sharing knowledge gained and overseeing a wide-scale implementation of BIM processes across the QEB Estate. As a direct result of the CEM project, pilot project, and resultant implementation exercises, a BIM approach has been established as the norm for subsequent projects, and they're now embarking down the route of organizational information requirements, asset information requirements, and EIRs. I suppose that's where I can only get to, really.
Yeah, I think we should probably stop there. So thank you very much.
Thank you.